How robots could restore the relevance of Stugna-P and other Ukrainian ATGMs. January 2026. Subscribe to Defense Reports, your go-to source for timely, in-depth military and defense reports. I'm Alex. Join me with Aria in the latest Deep Dive by Defense Report for a sharp, no-nonsense breakdown of the latest in global defense news, military technology, and strategic developments. And today we're going to cover, well, a massive shift in how this war is being fought.
It really is, Alex. We're seeing a dramatic transformation. The battlefield has become, for lack of a better term, hyper-lethal and almost completely transparent.
Hyper-lethal, what do you mean by that exactly?
I mean, the sheer density of drones, of electronic warfare, or EW,
Correct.
it just makes traditional military tactics almost obsolete.
So it's adapt or you're gone.
It is extreme technological adaptation, not just to win, but simply to survive.
So that's our mission for this deep dive, to
Yeah.
explore how Ukraine is leveraging AI and robotics to build strike capabilities that can actually function in that environment.
Right, capabilities that are EW resilient.
And we're going to look at how this is breathing new life into older but powerful weapon systems, specifically the Ukrainian Stugna-P anti-tank missile.
And that's really the core insight here. We're going to look at the solutions that just defy single jamming things like the return of laser guidance and even fiber optics.
It really comes down to one thing, then.
It does. Ukraine's ability to move the human operator out of harm's way. That's the key to maintaining momentum in this brutal war of attrition.
Okay, let's start with that hyper-lethal environment. It feels like drones have just erased every rule we thought we knew.
They absolutely have. Drones now define the conflict space. We're seeing reports that up to 75% of combat losses on both sides are from drones.
75%? That's astonishing.
It is. And it means large-scale maneuver warfare is basically dead. If you mass a column of tanks, you're just presenting a huge target.
And the economics of it are just insane.
Completely asymmetrical. Think
Yeah.
about it. A $4 million main battle tank taken out by an FPV drone that costs, maybe under $1,000 to build?
Wow. And even the more advanced drones are cheap in comparison.
Right. The Shahed 136 that Russia uses costs maybe $20,000 or $30,000. That's about 30 times less than a typical cruise missile. The attrition math is just brutal.
So with drones everywhere, the obvious response is anti-drone systems, jammers, that kind of thing. But they don't seem to be working.
They're not, because modern electronic warfare is so much more subtle now. It's not about just blasting a powerful signal to block GPS anymore.
It's evolved past that.
Way past that.
Yeah.
The goal now is what military analysts call insidious degradation.
Insidious degradation. Unpack that for us.
Okay, so instead of just killing the signal, which would trigger an alarm on the drone.
Right. The operator would know they're being jammed.
Exactly. Instead, the EAW system holds the drone's receiver in this constant state of near failure. It feeds it just enough noise so it never gets a clean signal lock.
So the drone doesn't think it's jammed, it just thinks it has a really bad connection?
Precisely. The system just says poor signal quality or position uncertain. So the pilot can't make a precision strike, but they also don't switch to a backup plan. They just abort. It's incredibly effective.
So if you can't trust the radio frequency spectrum, what's the answer? You have to either make your own signal foolproof or get off the airwaves completely.
That's the choice. The first solution is what's called assured PNT positioning, navigation, and timing. You use high-end inertial navigation systems, or INS.
Gyroscopes and accelerometers.
Exactly. It tracks movement without external signals, but it's expensive, and it can drift over time.
And the second, more radical option.
Abandoning the RF spectrum altogether. This is why we're seeing a comeback for things like fiber optic guided munitions.
The guidance signal travels down a physical wire.
The physical fiber line, yep. It's completely immune to jamming. The video feed is perfect. The connection is unbreakable, no matter what EW the enemy is using.
That sounds like the perfect solution, so why aren't they everywhere? There has to be a catch.
The catch is mobility in range. You're physically tethered by a spool of cable. It adds weight, and the length of that cable is your maximum range. It can tangle, it can break. It's a fantastic solution for, say, a fixed defensive position, but it's not going to replace your highly mobile RF drone.
Okay, so that sets the stage for the big pivot to robotics. This is all being driven by the human cost of the war, right?
It's pure survival and manpower conservation. With high casualties, the goal is to get your soldiers out of the line of fire and replace them with unmanned ground vehicles, or UGVs.
We've seen UGVs used for logistics, medical evacuation, things like that. But the big story has to be the DevDroid UGV on the front line.
That case study is a game changer. The DevDroid is essentially a heavy machine gun on treads, operated remotely.
And it held a frontline position by itself for, what was it?
For 45 days, completely solo. The operators were safe in a bunker far behind the actual line.
45 days. How did it even manage things like reloading?
That's the smart part of the design. It's integrated with logistics UGVs. But the main point, the headline, is that it held the position, and the Ukrainian side took 0 personnel losses in that sector.
0 losses. That's the metric that matters.
That is technology directly saving lives.
So let's connect this back to signal resilience. Ukraine is dusting off Cold War-era laser guidance as a solution to modern EW. Why is old tech the answer?
Because a laser beam is light. It's in the optical spectrum, not the radio frequency spectrum, so it's inherently immune to RF jamming.
You can't jam light with a radio wave.
Exactly. So developers are putting laser targeting modules onto drones, like the FRDM R34T quadcopter.
So the drone becomes a forward observer that paints a target with a laser, and you can't jam that painting process.
Right. And it gives targeting data for artillery or airstrikes up to 5 kilometers away. And it's not just for high-end systems.
They're putting this on the cheap FPV drones, too.
They are, retrofitting them with modules to go after laser-designated targets.
And what does that do for the FPV's range?
It's a massive difference. An FPV, with just its camera, is effective out to maybe 800 meters. With a laser module, it can automatically engage a painted target up to 3 kilometers away, flying right through any electronic warfare.
But wait a minute. If you're painting a tank with a laser, don't modern tanks have laser warning receivers that scream incoming?
That's a great question, and it's a calculated risk. The key is that the engagement time is incredibly short. We're talking seconds of illumination.
It's not a continuous beam.
No, it's a quick paint just before launch. And in cluttered terrain, it's very hard for a tank system to immediately localize that and react in time. Right now, the benefit of EW immunity is worth the small risk of detection.
Okay, so laser guidance solves the signal problem. But what about the final attack run? That's where AI comes in.
This is the real force multiplier. Ukraine is developing these tiny modular AI software components. Some are literally smaller than a bar of soap.
And what do?
They provide functions like automatic target recognition and, most importantly, last-mile autonomous navigation.
Explain that last mile part. Why is that so critical?
It takes over for the final few hundred meters. This is where the drone is most vulnerable to localized jamming. But more than that, it removes the human factor.
Pilot fatigue, stress, a shaky hand.
All of it. The AI takes over, flies based on its own locked target image, and it doesn't get tired or stressed. It neutralizes local EW, and it eliminates human error.
And what's the impact been on success rates?
It's profound. Strike success rates were hovering around 10, maybe 20% because of jamming and human factors. With this last-mile AI, they're jumping up to 70 or 80%.
70 to 80%, that's a strategic shift.
A massive one. It means fewer drones lost, fewer repeat missions.
Which brings us to the Stugna-P, an anti-tank system from 2011 that is suddenly one of the most relevant weapons on the battlefield.
Exactly. The Stugna-P, or SCIF as it's known for export, is a heavy laser beam-guided missile. Its core tech is a perfect fit for this environment.
And it has that built-in safety feature, the remote control.
That's the key. The operator can be up to 50 meters away from the launcher, connected by a physical wire, controlling it from a protected position.
That 50 meters is a lifesaver now, isn't it, with hunter-killer drones looking for operators?
It's absolutely vital. It was a forward-thinking design that is perfectly adapted for today's war.
And it still packs a punch against modern tanks.
A huge punch. The 130-millimeter warhead can penetrate 1,100 millimeters of armor, even behind explosive reactive armor. That's more than enough to take out virtually any main battle tank on the field.
So they've already been upgrading it, adding things like a laser rangefinder. That tells you they're doubling down on this laser tech.
It was a clear choice based on what works. But the long-term vision is where it gets really interesting. It's about connecting the Stugna-P to the robotics push we talked about.
Mounting a Stugna-P on a UGV, an unmanned EW-proof tank hunter. But that can't be as simple as just bolting it on, can it?
No, it's a real engineering challenge. You're bringing an analog wired legacy system to a modern digital unmanned platform.
You have to build a translator, basically.
A technological bridge. Precisely. They have to develop digital modules that can replicate the electrical signals from the human operator's control box and feed them to the missile launcher.
So they're using those same AI modules for targeting and navigation on the UGV.
Yes, and then integrating that with the Stugna's proven jam-proof lethality. It overcomes the missile's biggest weakness, which is its weight and lack of mobility, and turns it into a fully robotic asset.
The innovation isn't just a new weapon, it's making an old, reliable weapon resilient for the modern age.
That's the lesson for every military right now. Resilience through smart integration beats a brand new, unproven system every time.
So let's zoom out. This whole fight is forcing countermeasures from the super high-tech to the, well, almost archaic.
That's right. When you can't rely on electronics, you go back to physical solutions. We're seeing widespread use of simple nylon nets and steel mesh cages to protect everything from trenches to aircraft on the ground.
Just a physical barrier.
Sometimes it's the only thing that works 100% of the time against a cheap drone.
And for the soldier on the ground, camouflage has taken on a whole new meaning.
It has. It's now about defeating thermal and infrared cameras. Drones own the night. So there's this critical need for special thermal ponchos and suits that mask your heat signature.
Your standard camo pattern is useless against a thermal camera.
Completely useless. This isn't just gear anymore. It's a basic survival tool.
The sources suggest, though, that Ukraine's real advantage here isn't just the tech itself, it's organizational.
That's the secret sauce. Bureaucratic agility. They have managed to streamline their procurement pipeline to a degree that is, frankly, shocking to most Western militaries.
How are they doing that? I mean, how do you get a new piece of tech to the front in weeks, not years?
By creating direct feedback loops. They have small, innovative startups working directly with units on the front line. The funding is fast-tracked.
They cut out the middleman.
They cut out years of red tape. A traditional military procurement process can take a decade. Ukraine is doing it in a month. It allows them to iterate and adapt at a speed their opponents simply cannot match.
So when we put this all together, what does it mean for anyone watching the future of defense?
It means that true technological advantage now rests on two pillars. First, a flexible industrial base, and second, the ability to smartly integrate your existing proven systems with new AI and robotic platforms.
And it all comes back to taking the human out of the most dangerous spot.
Exactly. The future is about EW resilience and removing the human from that final point of risk. Any military that can't do that and do it quickly is going to be left behind.
That's a powerful point. We've seen how robotics and laser guidance can make an older system like the Stugna-P a decisive asset against the most modern armor. So if this blueprint for resilience can revive one platform, what scope does it suggest for rapidly upgrading the huge stockpiles of legacy NATO and European weapons to face this new EW-saturated battlefield? That's the question to think about. You've been listening to Defense Report by Alex and Aria, where we analyze the latest in military strategy, global defense, and advanced weaponry. Subscribe to Defense Reports, your go-to source for timely, in-depth military and defense reports. We'll catch you next time.